So we're looking at page 3 in the Unit P packet. And so these problems are more involving conic sections. The general process is to use completing the square to identify the nature of the conic, graph the conic, and identify any necessary points, etc. So in this case, we're looking at something very similar in structure to what we've been working with before. However, the y term is not squared. So there's no y term to square. Therefore, there's no square to complete. Let me undo that. So we're looking at x squared minus 8x. I'm going to leave a little space to complete the square for the x terms because I can do it for that, but not for the y term. I'm going to vacate the 16. I'm going to send that over to the other side. And then I'll use my nifty b squared over 4a technique to figure out the missing term for the x component. All right, so 64 over 4 is 16. It's part of the process that, depending on the numbers, you should be able to do in your head. Add it to one side, you add it to the other. We're looking at x minus 4 squared minus y is equal to 0. All right. Now, because it is a situation where only the x term is squared, it's not going to be an ellipse or a hyperbola or even a circle. It must be a parabola. Parabolas take on a couple of different forms. It could be in the form of y equals a times x minus h squared plus k. Or it could be in the form of x equals a times, I almost wrote an x, y minus h squared plus k. I'm on fire. So k squared plus h. It's an inverse relationship. So swap the x's with the y's, swap the h's with the k's, or swap x with y, swap h with k. So in this case, it's really just essentially telling me solve for y. All right, so we're looking at y equals the quantity x minus 4 squared. Now that's the same as y equals 1 times x minus 4 squared plus 0. Of course, we'd never write that. All right, but it does give us a sense that the vertex, and that's the most important point in the parabola in terms of determining its locations, its values, would be 4, 0. All right, the slope of the parabola is also very important. I'll get to that in a sec. All right, so using this, I guess I don't need the arrows. It's implied. Using this annotation tool, I can plot the 4, 0, and then maybe I realize, I don't have enough room. In this case, I do. But if I didn't, I would just pull one of these jammies and say, I'll move it over here, you know. But unnecessary in this case. All right. So the slope of this parabola is a 1, right? And that's because the a value is equal to 1. So that tells us that it's an ordinary shaped parabola. All right, I go with the 149 sequence. When plotting a parabola, that's assuming I want to do it by hand and not using technology. So a serves as the multiplier of 1, 4, and 9. All right, so for every step out in the x direction, you're going to go up 1, then you'll go up 1, 2, 3, 4, 5, 6, 7, 8. Oh, I would need one more, so maybe I do want to move some things. But I don't need to move it as much as I did before. And so I'll just do it like that. And then, whoop, see? Look at that. Super easy, barely an inconvenience. All right, so 1, 4. and then 9. So 5, 6, 7, 8, 9. We have symmetry in a parabola. If you wanted to get the y-intercept involved, you could. Although it'd be a little on the large side here. So I'm not going to plot that. All right, now this is where I always struggle. Ooh, okay, so far so good. Oh, okay, it's going off the rails. It's going off the rails. All right, I made it. Ooh, struggle. All right. Then, of course, there's this that I can do. Okay, so that's what the parabola ought to look like. Label it up if you want. The axis of symmetry corresponds with the h value. In this case, x equals 4. You can plot that if you want. Not really necessary in this case. If you're dealing with the inverse, it would be a y equals. All right, so it would be y equals whatever the k value is. So just something to be mindful of. All right, so that's your parabola. Oh, and you know, I've been kind of neglecting this. I have the screen right here. If you have x squared minus y minus 8x plus 16 equals 0, in this implicit form that was given to us, you can always just plot it in Desmos, come up with a graph, and then just kind of reverse engineer the equation from there. Because as you hopefully know, if you know the vertex and the slope, then you can come up with the equation. All right. When I say slope for a parabola, because we know it's a variable slope, the slope I'm talking about is the 1 unit slope. So the single unit away from the vertex, what is the slope of that line segment if there was a line segment there? All right, in this case it would be 1. So you know your leading coefficient is 1, identify the vertex, and you have your standard form. All right, so you can kind of go that way too. And it would work with any of these general forms. All right, it's just, you know, you're not always going to get a parabola, so, you know, you can always use that technique. All right, so number 6, 9x squared minus 54x, leave a little space to complete the square, plus 25y squared minus 50y, leave a little space to complete the square because we can in this case. We have both terms of the y expression available. It's equal to 119. I'm going to smidge everything over to the leftish smidgerooski here. Anyway, all right, and we're going to do the b squared over 4a for each part. You know, sometimes even I don't want to do the computations. So, division symbol, negative 54 squared, that's my b squared, divided by 4a. Well, that part's easy. That should be 36. All right, so I'm popping in an 81. Add it to one side, you got to add it to the other. And then negative 50 squared, that's 2,500, divided by 4a. That one's easy, so that's a 25. Oh, poor quality 25. Actually, I wasn't even making a 25 there. I was making a plus symbol. It went off the rails big time. All right. So this looks like it's going to become a 225. All right. The left-hand side, we can factor out a GCF of 9. Over here, I can factor out a GCF of 25. So 9 times x squared minus 6x plus 9 plus y 25 y squared minus 2y plus 1 is going to be equal to 225. All right. So then I can divide everything by 225. And the big question, I think, would be on some people's minds at this point is, how would we know to divide by 225? And that's because you're dealing with a conic section, specifically an ellipse or a hyperbola, because both the x and the y terms are squared. In this case, it's an ellipse because of the plus sign separating the two fractions, or two would-be fractions. And so because of that, the standard form, as we talked about, when did we talk about it? Way back when on page 1 with number 1, the standard form involves the right-hand side equal to a 1. All right? So simplify, we're talking x minus 3 squared over 25 plus y minus 1 squared over 9 equals 1. All right, the center is going to be equal to 3, 1. So I'm going to make my axes. I'll reorganize it a little bit, make it look a little nicer. So 3, 1. Then I'm going to go left and right 5. I'm going to go up and down 3. And I'm going to draw my ellipse. Oh yeah, that's going to be hideous. All right, I clearly didn't go up and down 3, so let me fix that real quick. I mean, I went down 3 from the x-axis. I didn't go down 3 from the center. All right, so that's pretty close. A little bit better. All right, now I just need my foci. The foci are going to be along the major axis, so that's going to be this. Foci are going to be along there somewhere, and we talked about that as being the square root, distance from center to focus. It's going to be the square root of the difference between those two denominators, and we talked about the reason why. All right, 25 minus 9 is 16, so we're talking about 4, plus or minus. So 1, 2, 3, 4. We got one right here, and we have one right here. So my foci would be at negative 1, 1, and 1, 2, 3, 4, 5, 6, 7, 7, 1. All right, got a couple labels here. Clean that up a smidge. And there you go.